Hello. In this video, we're going to look at how to find the length of a side of a right-angled triangle using our primary trig ratios. This video has been set up such that on the left-hand side we have the question, and on the right-hand side we have a calculator. The first thing we want to make sure we understand when using our calculator is that an angle can be measured in two ways. It can be measured in degrees, or it can be measured in what are called radians. So your calculator needs to know what unit of measurement you're using. So one thing I say to students is make sure you memorize sine of 30 degrees. Sine of 30 degrees is 0.5 because if you memorize that, you can type it into your calculator. As you see I have here, hit equals, and if your calculator is in degree mode, you should get 0.5. And notice I don't. So that means my calculator is working in radians. So I have to make sure to change the angle unit into degrees. So make sure you know how to do that on your calculator. And whenever you start to do some work with angles, make sure that the mode is set appropriately. So notice now if I take sine of 30 degrees, I get 0.5. Okay, let's come over to this problem now. So the first thing I notice with this problem is that I have a right angle triangle. The unknown is a length, and I'm given an angle, and I have one other side. So what I'm going to do first with this problem is I recognize that I'm going to use my primary trig ratios. And so I'm going to write out the helpful saying so ka toa. So I need to decide if I'm going to use sine, cosine, or tangent to find this length z. So what I do is I look at the angle that I'm using, and I know that I have to have an angle in my calculation, so I'm going to check mark sine of an angle, cosine of an angle, tan of an angle. And now I'm going to actually label the sides relative to this angle. So the 4 would be the opposite side, and the z would be the hypotenuse. So if I'm given the opposite, and I have to calculate the hypotenuse, so there's the opposite, there's the opposite, I have the hypotenuse, Once I get 3 check marks, I know which primary trig ratio to use. Now of course you don't want to do this every time, and with practice you can pick these out. But when you're learning, sometimes having little patterns to follow is helpful. So that means that we're going to take the sine of 53.13 degrees. So sine of 53.13 degrees. And that's equal to the opposite, which is 4, over the hypotenuse, which is z. Now a couple things to note here. First thing, notice that I've actually put a degree symbol. If you don't put a degree symbol, you're saying that you're working in radians. Second thing, what students sometimes do here is now they go with their calculator, type in sine of 53.13 degrees, and then write it along decimal. We want to leave sine as 53.13 degrees, sine of 53.13 degrees in that form until the last possible moment. The minute I write this down as a decimal, I'm introducing some error into my problem. So remember, sine of 53.13 is simply a number. This is just a number, and I'm going to treat it the same in my algebraic techniques. So I have to get z by itself. So the first thing I'm going to do is I'll multiply both sides by z. So I'll get z times sine of 53.13 degrees equals 4. Then what I'm going to do is I'm going to get rid of sine of 53.13. So I'm going to divide both sides by that. So I say sine of 53.13 degrees. Divide this side. Sine of 53.13 degrees. There we go. So what happens then is these cancel out. So therefore z is equal to 4 over the sine of 53.13 degrees. Now, once I've done this, I can now type this into my calculator to get my answer. So let's come over here, my calculator, 4 divided by sine of 53.13, and then I'm going to hit equals, and I see that that's approximately 5.000. Students will often say, how many decimal places do I take this to? And I always like to say, if you're not sure, take it to 3 decimal places. And then I'm done. I hope this video helped.